grande dicionário enciclopédico da Madeira veja a luz do dia. A Agência de Promoção da Cultura Atlântica está a ter dificuldades em encontrar financiamento para publicar, com qualidade e em várias línguas, os 10 volumes que reúnem 7 anos de investigação. Paulo Anastácio.
José Eduardo Franco, o coordenador do projeto, considera que todo o conhecimento reunido e que faz perceber o pioneirismo e a dimensão internacional da Madeira em diversos domínios não pode ficar na gaveta.
Estamos a trabalhar fortemente para preparar os 10 volumes da enciclopédia e até para traduzir para várias línguas, 2 línguas nomeadamente, inglês e espanhol. Estamos a sensibilizar...
Well, as we can see, we've got the radio working again. The last, when I left off last, what we'd had is a confirmation that the FM was actually receiving very, very distorted, pretty badly. That the AM channels were also receiving, again, very distorted, very badly. And I then embarked on the rather thankless task of changing out all these capacitors. I mean, these guys are bad enough. They were all leaking really, really badly. And in the case of the electrolytics, one of them, as I mentioned before, was completely shorted out. This guy over here, cathode bypass cap, was completely shorted out. The discriminator cap, this one over here, wasn't too bad. It didn't read too badly, but it was also leaking a little bit, so I replaced that as well. And all these Hunt capacitors were changed. That meant that I left in some of the other, the micros, a couple of ceramics in there, I believe they are, and I tested a few of those and they were fine. But all the wax caps, and that was these with the exception of one, and all the Hunt caps, really all the Hunt caps, were swapped out. Now this is quite a thankless task because these guys have a problem. They are incredibly brittle and they break. So even if you want to just test them, there we go, see that? The plastic cover is actually something that cracks off. Now even if you just want to test them, when you desolder one of the points, something will crack. So you end up having to remove them all. Now what happened was, I started with the obvious, these guys, did some testing and found that they were all leaking pretty badly. And I'll show you one or two in a minute. And then I started with the Hunts because I started replacing everything from the power amp back. I followed my usual routine of starting at the power supply and then the power amplifier and moving backwards into the actual radio circuit. So all you see here, this whole section here, is really the power amp stage. And when I finished replacing caps on the power amp stage, and there were quite a few, I mean everything that's in blue was replaced, I realized that the problem was still not here, because when I put in a signal into the gramophone input, I actually got an undistorted sound out, which meant that this part was fine. So the logic is this: if I had distortion just on the AM section, I'd have to look at the AM section down here and part of that there. If I had distortion on the FM section, I'd have to look at this over here. As it happens, I got distortion on both the FM and the AM, which meant that the main problem causing the distortion was not here, or rather not there, the FM case, or here, the front end of the RF for the AM. This is the switching and the oscillator sections. So I guessed it wouldn't be in one of these stages, it would be in the amplifying stages that go between the input of these two signals and the power amp stage. So the problem had to be in here somewhere. And as you can see, apart from capacitors that were changed over here, there isn't much in terms of components on this section. These are literally the coils, the IF transformers that fit into the stage here with the IF amplifier stages in between. So going back was the logical thing to do, and I then started finding that all the capacitors were gone anyway, so I changed them. I started changing them all, and everything that I've done here teaches me that you should check your work stage by stage, because if you change something over here and you short something while you're doing it, you find you create a new problem. So the thing to do is you replace a component or two and test it. See if you've got the same problem or better. The idea is that you get better. And strangely enough, I kept replacing components till I finally realized that nothing was happening. And that's when I found I'd forgotten this guy over here. This is one little filter cap. It's a 4 nanofarad filter cap that filters the B plus that's going through these coils to that preamp, that IF amplifier, and also to the supply of the ECH81. So when I replaced that guy, which I'd forgotten and hadn't seen it on the actual radio, this thing just came to life. Literally the second to last, because there's one more capacitor I changed after that, literally the second to last component that I changed on this whole system. That's the way it works. All right, so done all that, haven't actually touched the FM block yet, haven't touched the RF section, haven't touched the oscillator section, and we've got the radio function coming back. So the next thing to do, I'm going to show you the inside of this thing. It looks like it's got some yellow spotted fever with all the capacitors in place, and then we'll plan it from there. So that's what the inside looks like now. All the yellow capacitors are the replaced capacitors. There are a few orange ones here as well, simply because of where they were and components I had available. But as you can see, just about, well, the whole place is littered with replaced components. I used a little Weimar cap over there because I had run out of the particular value. There's another orange drop type cap, polyester. These guys were all Hunt capacitors. And the advantage of the Hunt capacitors, when they first came out, I think, were great, because when you replace them, you realize your problem is space. So the Hunt capacitors are very, very small for the values they represent. And when they were first used, I think the engineers must have thought it was a great idea, because the amount of space you saved was incredible. And now, even replacing it with modern capacitors, you can see that a lot of space was used that the Hunt capacitors did not occupy. The Hunt capacitors actually fitted nicely, snugly into the back of this radio, almost unobtrusively, because of their size. Unfortunately, they were very brittle, and that then resulted in the values going up because of humidity getting in, and also they leaked a lot. The other challenge that I found here is that the way these components are wired in, they're completely twisted into the solder point. So it's very, very difficult to unsolder them and remove them completely, which meant that I had to cut them and use that, I can't remember what these things are called. You coil the end of the component and fit it into the little bit of wire that's left over. You can see a good example down there. Actually, you can see two examples down there. It creates a very, 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 very good contact, and it doesn't damage the solder point, which in this case is that pin 8 and 9 of that tube. So you don't do more damage. And it's not the way that I prefer to do it, but it's the only way possible with a radio like this, unless you want to damage some of the solder tags or the 2 pins that you're soldering them to. What I've done here, I've still got that resistor cut off. That resistor you see there is in that feedback loop from the power supply to the cathode of the EL84. It's the hum stopper, and I've cut it out, haven't actually put in a new resistor, because I wanted to see what the effect was. Quite frankly, I'm going to be able to measure it later, but quite frankly, I don't notice any hum. So I don't think that circuit is strictly necessary. I think this radio is silent enough, but I'll do a before and after and see what the result is. So much for capacitors. Right, onwards. Once I got that all done, I wanted to check the, wouldn't call it the accuracy, but I wanted to see just how close the reception or the receiving was to the marked frequencies on the scale. So taking some known frequencies from some of the stations that I received quite well here, I started trying to determine where they were on the scale, and this thing was completely wrong. In fact, it was so wrong that I realized it was inverted. What was happening is, when I was looking for the channel on the station on 88, I was getting it up there. So that sort of answered the question, that the dial was working backwards. And when I referred to the data, I realized the chord they had in here came straight from there, through there, and went in there. That one came straight from the bottom there, up here, and into there. Which meant that when you turn that way, this thing was turning that way. Turning the wrong way, basically. And I realized they'd changed the dial chord. At some point it must have come out. And they'd wired it wrong. This is actually in reverse. The guy that comes from the bottom here goes around here and then in there. That guy coming from the bottom on this end goes around there and in there. And as I said, I have the data sheets for this. And this is one detail that's particularly clear in that data sheet. So it wasn't a problem to rewire this. However, the cord was too short. So I ended up using another alternative cord. This is a combination of, it's just basically hardware store cord. I don't know what you call this. I've got this cord, it's about the same thickness as the dial cord, and it works perfectly. I just started winding it, removed the connection from the pointer, wound it in place, and then with the right number of turns they have, with this thing rotated completely anti-clockwise. And when I ended up getting to the other end, then you tighten it and tie it to the spring that's in here. These two springs are the ones that cause tension on this cord to make it grip. So then that was tightened, and it might slip originally. You might have it too short. In one case I had to tighten a bit more. But the way to get this thing to work is, you see this cord is a little bit stretchy. But once it settles down, you get the final position, you tighten it in there, and then you tune left and right a few times, and it sort of adjusts on the both sides by the tension of the spring, so that it starts grabbing properly, and it is grabbing properly now. So we've got our dial working properly again, and what I found now is that by adjusting the position of the actual pointer, which connects to the back here, you loosen it, you move it to the end of the dial, tighten it on there, for example, and then check the stations again. And I found that it's spot on. 88's on 88. There's one on 100, which is just off. And I actually receive up to 101.6, because that last station I had here, I know is at 101.6. So this thing is receiving higher than its rated 100 megahertz, which is also specified in the data sheet, which is strange because the point there actually goes way beyond the 100. So it's actually very well aligned. And I checked the RF as well, the AM as well, by simply sending a signal with a signal generator at a known frequency. And what I found, for example, on 50 meters, which is 6 megahertz, it was like off by 1 millimeter. And then I checked at the other end of the dial, and again, very, very close. So this tells me that I don't need to do an RF alignment on this radio. The same applies for the medium wave and the long wave. And that's a relief, because those, what you need to adjust here, you follow the data sheet, which is pretty explicit, pretty clear. And you then have to adjust those inductors and tuning capacitors and variable capacitors at the bottom, underneath. And those things are stuck. Those things have been glued in place with paint, just to prevent them from being messed with. And it's always a risk when you play with that, because you can actually make it worse. You can actually break one of the wires, crack one of the cores. And so if you can avoid it, fine. If you can't, well, that's just something you need to do. In this case, RF alignment is not necessary. We will be doing an IF alignment on the AM and the FM, just to ensure that we're getting the best signal possible. But that's the job so far. What needs doing? Well, I want to show you the result of some of these capacitors and the state they're in before I finish here. And then the next stage is to do the IF. I think now that I know it's working, I'm going to actually do a cleanup of the faceplate and all the brass and clean up all the knobs, which still needs doing. This front section is not being cleaned. So this thing will be, once the final job is done, this thing will be ready to do the final testing and do the final IF alignments, and then move on to the cabinet. That's it on this so far. Let's test this guy over here. This is a 0.2 microfarad, 350 volts. So we can go to the top of the scale on this leakage tester. Maximum is about 350 volts. So voltage is low. Put it on the 100 milliamp scale, nothing. Let's start upping the voltage. There's 100, 150. 200, 250, 300, 350. No shorts, but we see a slight tweak on the needle there. Let's put it on the 10 milliamp scale. And there we have it, 1 milliamp. If we go to the 1 milliamp scale, it's just over 1 milliamp. So this thing is leaking 1 milliamp. At 330 volts, 340 volts. Dead. Right, next. When I turn the meter off, it actually discharges it through a 47k, or I think it's 47k resistor. So it should be safe to handle. Let's try another one. This is this again is 350 volts, 0.05. Let's see what we have here. Put it on, start upping the volts. I can see it move. And another reason I know that it's leaking is because this isn't reaching 300 volts even, which means it's dropping. There's a current limiting resistor in there, and it's dropping. Now I can see the leakage is increasing. This is on a 100 milliamp scale. There we go, 10 milliamp scale. This thing's leaking 6 milliamps. And it seems to be climbing. Time to put that guy off. Drop the voltage. Another one dead. Let's try one of the hunts. This is a hunt capacitor. This one is 0.04, 200 volts, so we can't go over 200 volts on this thing. That's the only thing you've got to be careful of, is that you don't actually exceed the voltage. So put it on. There's about 150 volts. Let's see if it's leaking at all. Yeah, it is actually. Right, 200 volts. On 10 milliamp scale, 1 milliamp leakage. Really bad. So, another one dead. And that's just the leakage. I haven't even started on the values. The values are completely off. Here's another hunt. This one is 400 volts, so I can go to the top end. You have to be careful with this because when you do put it on, you have high voltage. It is current limited, but it is high voltage, so 400 volts. Let's put it on there. Up this, no sudden movements on the meter. Looks like this one may not. On 10 milliamp scale, no leakage. On 1 milliamp scale, no leakage. On 100 microamp scale, there's about 2 microamps. See, not much leakage. Now this particular one, let me just measure the value quickly. The value of this guy is usually the problem. Some of them are actually not leaking, but their value goes completely up. So if we measure this guy, let me just measure it without setting this whole thing up. This one is measuring 5.5 nanofarads, actually lower than the 10 that it's supposed to. So again, unpredictable. And there we have it. These capacitors are all trash. These guys were expected. These I expected anyway. But the hunts, it is a first experience for me. I was warned that I'd have quite a job getting rid of them, and it's proven correct. So all those were changed. They will be kept. I keep all the old components in a little bag and attach it to the radio on the inside so that basically it's all there in terms of value, antique value if you want to call it that. But they are absolutely useless. And the result so far is we've got a working radio. Right. Enough for now. I'll get back to you as soon as there's more progress.